Second speaker is a very valued colleague of mine, Cengiz Ӧztireli, who sadly is not actually in Cambridge today, although his office is along the hall from mine. Cengiz is a pioneer in the use of AI methods in the creative arts industries, especially during the period he spent at Disney Research, where I only just realised this morning that he was affiliated with ETH Zurich, and Maria also has worked with ETH Zurich, so I think we've got a bit of a Swiss axis. Leo, my co-organiser, also did his PhD in Switzerland. Maybe we should be in Switzerland today, not in Cambridge. But Cengiz had a glittering career full of awards for his work in generative image production, in animation and 3D modelling, human motion traction, and many other things. And looks like he's all ready to go. Is there anything I've forgotten, Tony? We're away.
Thank you very much, Alan, for the nice introduction. Also, thank you very much for inviting me. Unfortunately, I'm not there. And I actually tried to find a stable connection for a while, but for now I got it, so hopefully my slides should be up and you can hear me well. Thanks a lot, actually. This is a really interesting event. I would love to be there. But I'll try to explain a bit what's happening in my field, which is now a merge of machine learning, computer vision, computer graphics, to basically provide new types of creative tools to people. My title is obviously wrong. I actually chose it because it's wrong. I mean, there's no way we can create art. I mean, I'm not, of course, going into the discussion of what's art, what's not, but basically the tools that we have at the moment, there's no way you can just type what you want and it will give you that piece of visual. I mean, you cannot have such a prompt and hope that any GPT will provide you, the desired output. Actually, can you hear me? Is there a problem?
Can you hear me, James?
Can you hear me well?
You're muted.
So we're just adjusting the volume level in this room, but also you seem not to be in presenter mode.
But it might be this mic. You think it's this mic which is creating some issues. This one. Wait, this one? I think so. Because we have multiple mics on that are.
I'll just.
Okay.
Can you see my screen now?
We can see your screen, but we're just trying to work out the sound in the room.
Mm-hmm. I could also try to speak up a bit if the volume is not.
It's actually just the echo. I think it's muted. It's something on our side.
Is it good now?
It might be getting better.
Do you have a volume control for the operating system?
I don't know if Andre is.
Is it good now?
Thank you for doing the mic testing, Cengiz, constantly. We're trying to work it out.
I think Maya, something we're on mute.
No, but I think he's able to hear, I think. No?
No, you're like...
We are on mute.
I think it's acceptable. I think we better continue.
Okay.
Where's the...
Yeah, that's what we should. That's our canary. I'm going to have to go.
Should we carry on? I think we can carry on, Cengiz.
Can you hear me well?
I think just give him the sign so he knows that it's all good. And
Yeah, we got to go.
Can you hear me well now?
yes, but there is still like massive feedback, or not feedback.
Yeah, that's there is. Okay.
We need I see.
Can we get into 10 minutes? I think it's acceptable.
Yeah, no, not at all. No, it's sunshine.
Okay, thank you. Yes, thank you very much.
Did he hear you?
I don't think you heard.
I don't think he heard you. I think you just need to tell him again.
Sorry for the trouble. Can you hear me well now? Okay, so I'll just... I'll just continue, if you can hear me.
I think we'll leave it at that.
So shall I continue? Is it fine?
Yes, please.
Okay, sure. Sorry. So yeah, sorry for the trouble again that I'm connecting remotely. Yeah, so I was actually saying, so some people in my field and many people outside of the field think that you can just type something and it will give you what you want, which is obviously not true. And I actually worked with 3D artists for a while. I was sitting next to them in front of the computer, developing tools with them and for them for multiple years. So these are some of the top talents in the world in 3D industry, in particular the movie industry. And I know their processes quite well. I know the tools they use. And when these things came up, like with image generation and 3D generation, it was very obvious to me that there's no way we can match the complexity of what they can create. And also we cannot really control the way they can control what we created. That's why actually I chose this example of 3D characters, which is I think a really great example of what we can do with the current tools and where we can go from here and how this compares and contrasts with what we've been having in industry and in academia so far. I want to actually briefly start with the way that the artists, the 3D artists create 3D characters, and then I'll show you let's say, the modern, it's not the modern, but like this new workflows that some people in the world, some of them are artists, some of them are not, are using to create similar characters. When I say similar, because like there's still a big gap, but they're trying to go there. Then actually, I think it will really give a good idea about what tools we have and what's available, and what we can do, what we cannot do. So let me start with the character creation process normally in industry. So everything starts normally with a storyboard, and actually I saw some of these boards. I didn't take this picture because it was strictly forbidden to take pictures of storyboards. But actually they really have a wall. It's really like a wall full of these drawings and how that's how they start. And then once this is set up, they start thinking about what kind of animations they want to do with this for each of the characters in their movies. And slowly move on to the second stage, which is actually the design. Still, you are like with paper and pencil, and still you're not using the computers too much. And basically, these are the rough sketches of what you want to have and main features of the character. And this is really the second fundamental stage. And then comes to computers, the 3D part. And when you say 3D, you really start with some meshes. In this case, in the 3D movies case, that are really like well designed, so they can capture the shape well with the least amount of polygons. And then you also have textures and colors, so you can give some color to this whole geometry, and some textures also capture some of the details that you can represent geometry. So it's actually a complex, already quite complex 3D workflow. But then it becomes even more complex. You have a so-called rigging. And rigging basically means you're attaching controls to your geometry such that as you change the controls, the geometry defaults, the character defaults with the controls. And these controls are really, in a certain sense, complicated. From the artist's perspective, they're essential, because without them, there's no way you can animate the character, so you need such controls, well-placed, like skeletons and such boxes, as you can see around the eyes of this prop, etc. And basically, you have all of these controls for animating the character, deforming it all the time. And part of this is constructing the sculpture, as I said, and there are actually additional ones that you have to add as well. And then these are keyframes all the time to basically create the final animation. So this process is really complex again. It's rigging processes. There are actually people that only work on rigging, basically attaching the controls, attaching those controls to the meshes or the other forms of geometry that they have. And then on top of all these, there's also the blend shape creation. Blend shapes are basically hand-sculpted shapes that you can typically use for faces, creating facial expressions. And these actually come on top of all the controls that you have, because you want to get a bit more realism, a bit more control sometimes, or some details of the face especially. So blend shapes are also pretty important, and they also can get quite complex. And then comes the animation part, finally. Right, so then you can keyframe all those controls and basically just animate this character all the time. And here, timing is essential. Without the right timing, there's no way you can get the right style of animation. It could be realistic, could be hyper-realistic, could be for a particular director, because actually in the studios there are directors, and each director is responsible for different characters, or actually different shots of a character. And there is a director's style. We want to have that style in the animation. That's all about timing in this case. And then this is not enough. Then you have to render this thing, right? So then you will get post effects and all the effects around the character, including the shading, the fluids, and the lighting and shading in the scene. As I said, the final rendering of the scene, which actually can include complex reflections and everything. And this creates the final, if you want photorealistic, if you don't want it like a different style images random. So a very complex process. I just wanted to walk you briefly through this because I think really illustrates what these pipelines try to shortcut, right? Because you get all these steps and 1,000 people working with really complex tools for multiple years even sometimes to create a character. And then you're saying, well, I don't need any of this. So what I really need is basically a browser, a web browser. And obviously, this will just not work out of this one. So this is actually what I want to talk about. So I want to just show you how people have been building their workflows to imitate what I'm showing you, utilizing some of the latest techniques that we have. And when I say latest, it's really like a couple of months ago. Right, so a paper published 2 months ago, workflow created a month ago. Of course, these people are not really traditional artists in the sense that they don't work for high volume studios. They create their own projects with these tools, but basically they try to shortcut everything with this workflow I present now. And I think this is a really great example of how the tools that we've been developing over the last 2 or 3 years essentially have been used in practice to create,
it needs to be higher.
Let's say, a type of art or content. So everything starts with GitHub these days, and we have this stable diffusion code base that actually you can use for different purposes, but in this case we will use it for creating animations. So there's this animation utilities part of it, and basically people go and can download the code, the compile, etc., or they could just use it in the browser. There are ways to do it as well. And then what we can now do, thanks to some recent papers that published, again, just a year ago or so, is you can control the creations a bit more. than just typing text. In this case, we have a skeleton. Actually, can you see still my screen, because I'm seeing the screen?
Just let him know that it is.
Okay, cool. Yeah, so what we can have is basically now controls that go beyond text. And one type of control is a skeleton structure. This is not, of course, like an exact human skeleton, but it's an approximation of that you can get from some photos with approximation techniques, so you can just create it from motion capture data, or you can just do it by hand if you like. But now you can control the creation via such images of poses or of a character. And then, given this, you can actually start with an image that you can paint in black. Certain parts you can paint in black. And you can say, okay, I have this image. I hope you can see my cursor, actually. You get this black region that you painted, and you get this poses that you have equal to this algorithm. And it will output you a character based on your prompt. So the prompt is up here. There's some text. I don't think you can read it, but basically it's a prompt about this hawk-like, orc-like character. It's a green scaled skin, jagged yellow teeth, etc. So basically you can describe the character, and then you can just wait until you get something that looks okay. And I cannot show everything, but there's so many options here, like so many sliders that you can play with, so many algorithms you can choose from, and so many sort of checkpoints. Basically, each checkpoint is where you saved your trained model. And then there's also this hyperparameters and weights, and it's much more complex than just typing. Right? And these people actually have been playing around with this for months to get something that looks okay. Yes, but then you get something that actually looks like this, and then refined. And you can already see, so these are actually output from different runs. And this is also one thing to realize, right? So basically, these are randomized algorithms, and each time you run the algorithm, you actually get a different result. So sometimes you can get this one, or sometimes you can get the second one. I'm actually not showing you the converged results, just also illustrate that this takes time, right? So you get first this kind of blurry result, and it becomes refined and refined and refined, and it converges to something. And that's something you cannot really control, right? There's always this indirect controls. So that's basically the most important limitation of all these workflows. Everything is indirect. So if I go to any of these creations and say, well, I don't like the face, and instead I want the smile a bit larger, etc. There's some ways, but it's really complicated, and typically it doesn't work as expected out of the box. You have to try multiple times. But what you get here is actually the poses are okay, right? So like the first pose, the example is the first pose is like on the right. So basically from left to right, there's consistency, right? The poses are almost the same. And this is already, of course, a great advancement that we had over the last year, actually. And then what you can do, you can choose one of the characters that was created by this algorithm and say, well, I don't like certain parts. So that's, for example, the face. In this case, it's the pants. Face is really complex, but you can say, well, I don't like the pants. Basically, you can just paint over the pants and ask the algorithm to regenerate it. Right? There's something you can do. But if you want really fine control, let's say, yes, I want to generate a new pant, but what's the vehicle pattern? Right? So what's the garment? These kind of stuff, of course, there's no way you can control. And then what you can also do, once you're satisfied with initial results for some poses that you provided, is you can basically black out a part of this image again and change the pose that you want to have, and now you can have a pose, a new pose. And in this case, it's what you see on the left, right? So basically from behind, now you can see the same character. Now, one thing you can realize here is these characters are almost consistent, but not exactly consistent. I don't know if you can really clearly see well, but there's some kind of facial hair here, and there is no belt here. If you just look at the newly generated pose, right? If you look at what's generated from behind, the belt is missing, and some facial hair seems to be there. So basically, they're not exactly the same, but they're plausible. That's basically what you typically always get, unless you try 1,000 and maybe a million times. And then you get these three nice looking poses which you can actually use to create the character in further poses. Right? You can just basically iterate this process. You can delete one of these guys and input a new pose and generate a new pose and try multiple times, and then you get this range of poses created. You can just continue doing this one. And what you can also do is actually change certain parts of the character. For example, you can black out the legs, and you can say, well, I want the upper body to stay the same, but I want the legs to be different. You can do it actually, also with the same framework. And you can keep on generating more and more poses, which will give you, in the end, this kind of sheet, or let's say this set of poses which you can use to interpolate and animate your character. And this is the workflow, right? So this is what people use these days. And this is the most advanced workflow, actually, I've encountered. It's not me. So basically, me and my group, we've been working a lot, of course, with artists and artist tools. And these days, I'll be working a lot on those generative AI tools, both for images and 3D. But the way to put these into workflow is actually something I cannot do. Right? So these are all people who basically take our tools and try to think about, okay, how do we actually use this in a workflow which you can potentially create some artwork. And this is the way it goes. Like, there is no algorithm that will just output you like what you really want in terms of a 3D character. And this the same. I'm not going to like each and every example because there's like 1,000 of them by now. But basically, for each and every example, like if you want to create images or videos, if you want to create some other forms of art, like for example something that you can 3D print, which is actually a bit different than just 3D characters. There is no way you can just type and get what you want out of once. Now, all these advancements, of course, build on some fundamental algorithms that we've been also working on quite a bit. And there are a couple of different ones, but I wanted to highlight a particular one, which is actually the most popular one at the moment. And that's called stable diffusion. I'm not going to put too many details here, but I just want to give you an overall idea of how this thing works, because this is always the same, right? So we always have the same blocks. There, I think by now already 100 papers seeing the same process from different angles, like in terms of stochastic differential equations, in terms of some other loss functions, etc. But the concept doesn't really change. I'll not talk about the bottom part. That's a little bit more, let's say, not really complex, but basically the part that changes, that's a little like fluid. But the top part is actually quite stable. So the idea is you get an image or any kind of content, and you first encode it. So this E is the encoder. I hope you can see my cursor. I actually planned for, normally I don't plan of course like for cursors, but since I'm presenting remotely, I actually planned for illustrating with my cursor. But basically we have this E block, which is the encoder that actually takes that image in this case, and gives you something called a latent vector. So this latent vector is kind of a compressed representation of this image. And the forward diffusion process is just basically adding noise to this latent vector. And from Z0, then you can go to ZT, which is this kind of randomized vector. It's almost all white noise. So the forward process is not very interesting. But what people realize, actually, you can run the inverse process. And the inverse process starts from ZT and goes up to Z0, which you can then decode to get an approximation of the original image that you have. And the cool thing about this inverse process, this inverse diffusion process, is actually you can condition it on different stuff like text, images that I, for example, showed you, for example, images of poses of characters. Some other representations of 3D, some semantic maps that you have. So basically, you can do all this sort of conditioning, which means that you're just informing the system, that you're informing the inverse process with additional input, essentially. And then it actually trains quite well, which means that there's no like nonlinear optimization tricks you always have to change, right? So you kind of have a set of tools that you use for optimization, and you can just use them. And hyperparameter tuning is not a big problem, etc. So this is actually why it's so popular, because you can actually train it quite well, it's stable, and it scales to large data sets as well. So I'll not talk about more of this. I mean, actually, everything is quite simple, to be honest. Like all these Q, K, V blocks, they're basically just implementing some linear algebra and combined with some simple non-linearity, etc. So everything is really simple. Just the way this trains and generates realistic content is basically what makes stable diffusion so popular. And the pipeline I just showed you for creating animation was using stable diffusion. Now, this is all good, but as I said, the fundamental problem we're having is control. You can have all these indirect controls, right? You can paint like images you go to Microsoft Paint on black certain regions. You can do poses, and you can generate multiple times with different parameters. But all this kind of indirect control are there. But the level of control that an artist has on 3D character creation or any kind of creation, we don't have it. That's the main problem with such workflows. But of course, if you just flip the coin, then the difficulty of creating the content is significantly reduced, right? Instead of having all these tools in the 3D like Blender, Maya, etc., and all these like workflows that are really customized with plugins, thousands of people working for multiple years. Now you actually have a person not really trained for creating such animations and just have a web browser, not even a GPU actually. You can run everything like on a remote server for a moderate price. And then you have a 3D character. So we have these two ends now, and it's a little confusing time for many people because there are a lot of claims by companies that I will not name. They say, well, now you can just type and it will give you magically what you want. And some artists are confused, but is it really true? Are we, the studios will not need us anymore, etc. Also in the field there's a lot of confusion because not many people actually have worked with artists. And many people have a computer vision background, which means they've been working actually on analysis problems, not synthesis problems. So they also don't really understand the complexity of creation actually. But there is some mid-ground there, which is basically having a 3D application. Actually, this is a screenshot from a startup company. You have this 3D application, and you embed all these new tools into that 3D application. You could use Unity, you could use Blender, and now more and more plugins are coming up. I think next year we will see an explosion of these. And you can type, for example, what you want to have, and then you can select an object. You can say, I want to change the color of this object. So basically, it's kind of a co-pilot, right? So co-piloting, not for Microsoft Office, but for 3D applications. So this is kind of mid-ground now. And I should say, I really believe in this mid-ground. I don't believe that we will have like this completely non-3D workflows for 3D or non-art workflows, let's say, for art creation like typing. But I think these tools will penetrate in some form into the artist workflows. And that's actually what I believe will be at least the near future, maybe the next 10 years. And we already see it actually. This is an announcement, I think yesterday, that my wife forwarded to me. So basically, Unity has started integrating some of these tools into what they call AI marketplace. Basically, you can create some physics, you can create some objects, etc. and the share is already wrong, like 15%. So people also, I think, believe that these tools will be useful if they are used in the right context. Yeah, this is all I wanted to say today. Again, I really thank you for giving me this opportunity. I'm not sure if we have any questions, time for questions, but please feel free.
Thank you.